You're reading this article or watching this video, and chances are it's all being delivered to you by a beam of light. That's right. The modern internet doesn't primarily rely on satellites or wireless signals. Instead, it's powered by thin strands of glass that connect the entire world. We call them fiber optic cables. Welcome to Nexus Space. Today, we'll explain how do fiber optic cables work. A fiber optic cable is actually made up of ultra-thin strands of glass. Even thinner than a human hair, it consists of three main layers. 1. Core, the inner glass center where light signals travel. 2. Cladding, the layer of glass that surrounds the core and reflects the light back inward. 3. Jacket, the outer protective layer that shields the cable from water, damage, and wear. So how does it transmit signals? Inside a fiber optic cable, light doesn't travel in a straight line. It moves forward by bouncing back and forth in a zigzag pattern. This phenomenon is known as total internal reflection. Imagine light being trapped inside a glass tube, bouncing endlessly along the path, yet losing almost no energy along the way. And this light isn't just randomly flashing. It carries information, transmitting digital signals in patterns of 0 and 1, much like Morse code. That's the data we use every day. You might think that international communication relies on satellites bouncing signals around the globe. But in reality, 99% of global cross-border internet traffic travels through fiber optic cables. These cables are laid deep beneath the oceans, spanning continents and forming the true information superhighway. A message sent from New York can travel through these undersea cables and reach London, Tokyo, or Singapore in less than a second with virtually no delay. Fiber optics versus other transmission methods. Fiber optic, extremely fast, stable, low latency, but high installation cost, fragile. Copper wire legacy network, low cost, easy to install, but high signal loss, slow speed. Wireless Wi-Fi, satellite, flexible, no cabling required, but susceptible to interference. High latency, unstable. So when you tap to play a video or load a web page, it's not wireless signals floating through the air. It's a beam of laser light racing through glass at high speed, delivering your data. The core technology of fiber optics is using light reflections within glass to send data to the other side of the world. In the next episode, we will explore why can your phone access the internet. If you enjoyed this episode, don't forget to like, subscribe, and share.